Okay, we can get started. Firstly, we need to understand what hypothesis testing is. Let me begin by defining hypothesis. A hypothesis is a claim or an assertion or a conjecture. A claim which is neither true nor false unless proved otherwise. Let me try to give an example. What we know is that any person is not a criminal. That's what is known. Now, if there are allegations that somebody has committed a crime, then that is a claim. So what it means is that in any hypothesis testing, we should have two competing statements. The so-called null hypothesis usually denoted by letter H0, and the alternative hypothesis which we normally refer to as H1. So the null hypothesis basically is what is currently known, the status quo. Then the alternative hypothesis is the claim that is being made. Now, like the example that I gave you, where I said we basically know that everyone is not a criminal. That is our null hypothesis, H0. If there is a guess that somebody might have committed something, then we call that an alternative hypothesis. This alternative hypothesis is sometimes referred to as a research hypothesis. It is the one that will cause people to say, no, we need to research in order to either reject or fail to reject the null hypothesis. Now, before we proceed, I shall give you the ingredients. Some authors refer to them as ingredients to a test of hypothesis. The ingredients to a test of hypothesis are: 1, you have to state the hypothesis itself. Now, in this case, you need to specify H0 and H1. Then you also need to state what we refer to as the level of significance. The level of significance is known as alpha. I shall be explaining each of these ingredients in detail. Now you also need to specify what we call the decision rule. Now we also need to specify the test statistic. The test statistic, let me combine this as test statistic and critical value. Now the final ingredient is the conclusion. Why am I calling these ingredients? I'm calling these ingredients simply because ingredient is what is needed for you to perform the whole process. We normally talk of ingredients in baking, whereby you say you need salt, you need this combined together. Now in hypothesis testing, likewise, we also need ingredients. So if you are to test a hypothesis, these are the components that you need. If you put them together, they will give you a complete test, a complete process involving test of hypothesis. Now let us start with stating the hypothesis. Usually the null hypothesis will be given and the alternative will be given. Now the next thing is to determine the level of significance. What do we mean by level of significance? At this point, let me just define it, not in more detail. Level of significance is a probability. We are saying when you perform a test, there is a chance that you may conclude wrongly, and there is also a chance that you may correctly make a conclusion. Now, the probability of rejecting the null hypothesis H0 when H0 is actually true is what we refer to as the level of significance, denoted by alpha. It's a probability. Now, let me further expand on this so that we're on the same page. When we test a hypothesis, we don't conclude based on H1. We don't mention H1 in our conclusion. We need to only comment on the null hypothesis H0. So it's either we reject H0 or fail to reject H0. Please, I want you to take note that failing to reject is not the same as accepting H0. I know some text will actually say accept H0. I'm sure in our next segment I'll be able to explain in detail why do we say you fail to reject rather than saying accept H0. Now, when you fail to reject H0, so there are two possibilities. It's either H0 is true or H0 is false. Now, if you reject H0 when H0 is true, you commit an error. And that error is called type 1 error. Type 1 error. When you reject H0 when H0 is true, that is called type 1 error. So, statisticians know that it is more dangerous to make type 1 error. So they have fixed this error to be alpha. So you realize that alpha values are always very small. 0.05, 0.01, and 0.1. These are the normal alpha values that we use when we do a test of hypothesis. Now, we will go into detail with this level of significance as we proceed. But as of now, I think it's good to just appreciate that level of significance is a probability of rejecting H0 when H0 is actually true. Now, the decision rule, it's a statement that connects two values. Which are these values? The decision rule compares the test statistic and the critical value. So in other words, the decision rule tells us what do we do when the test statistic is lower than the critical value, and what do we do when the test statistic is above the critical value in terms of rejecting or failing to reject H0. That is the decision rule. Now, what is the test statistic? The test statistic is a value that is calculated from the sample values. Then we compare it with a tabulated value which is called the critical value. And we use that as the basis of either rejecting or failing to reject H0. And finally, we make a conclusion. A conclusion, we make it by comparing the test statistic and the critical value. Now, at this point in time, I think these things will make a bit of some sense if we proceed to go through an example. But before we go through an example, I need to explain some few more things. Now, in hypothesis testing, there are two types of tests. There is what is called a one-tailed test. That's type number 1. And 2, there is what we refer to as a two-tailed test. Now, what makes a distinction between a one-tailed test and a two-tailed test? Let us look at this one. The null hypothesis will say H naught. Suppose we claim that the average which we denote by mu1 is equal to another average which we denote by mu2. Remember, this mu is used to denote, to refer to an average. So the average for sample 1, for instance, is the same as the average for sample 2. Now, if it's a one-tailed test, we will have H1, average for mu1 is greater than the average for mu2. You see, what is known is maybe average performance of UNAM students is the same as average performance of students from another university. So average performance of students from UNAM will be denoted by mu1, and average performance of students from another university will be denoted by mu2. So this alternative hypothesis is now saying the average performance of students from this other university is better than the average performance of students from UNAM. So this is a one-tailed because we are saying in this case it's greater. What makes us say one-tailed is because it's tailed to the right in this case. Now, suppose our H1 was saying average performance of UNAM students is actually less than the average performance of the other students from this other university. We call it one-tailed, but in this case it's tailed to the left. Sorry? It's tailed to the left. Now, so these are two examples of one-tailed. The other one tailed to the right and the other one tailed to the left. Now, if it's two-tailed, our H1 should read mu1 is not equal to mu2. By saying mu1 is not equal to mu2, we are not claiming that average performance of students from UNAM is better than students from the other university. Neither are we saying it's worse. We are just saying the two are not equal. So this gives us a two-tailed test. And these are two examples of one-tailed test. Now, from this, it's clear that this is our null hypothesis. Then this is our alternative. So the alternative hypothesis or the research hypothesis determines whether we are talking of a one-tailed or a two-tailed. In this case, you can see that the first two gives us a one-tailed, and the last one gives us a two-tailed test. Now, before we proceed, it's good that I'm assuming that at this point you can perform a test of hypothesis involving one sample. As we can see, this is a test of hypothesis involving at least two samples. And in this course, we will only concentrate mainly on two samples. The assumption that you can perform a test for hypothesis test involving one sample is going to hold here. So, what I've given you is a test of hypothesis involving two samples, mu1 and mu2. Now, let's proceed. We also have other subdivisions depending on the distribution that is being used. So in this case, we normally talk of an Ttest or Z-test, depending on whether you are using the student's T distribution or you are using the normal distribution. So, I want you to take note that this is a one-tailed and this is a two-tailed. But under one-tailed, we can also have subdivision, where we talk of Z-test and Ttest. Same thing applies for a two-tailed. If we have a two-tailed, under a two-tailed we can also have a Z-test and a Ttest. right? The next question that comes in is, how do I make a distinction whether this is supposed to be a Z-test or a T-test? We are able to make a distinction on whether this is a one-tailed or a two-tailed based on the research hypothesis. But when it comes to Z-test and T-test, how do we make a distinction? Now, to use a Z-test, for a Z-test, we must have a large sample size. A large sample size. Now, in statistics, we define everything completely. How large is large? Because large sample size means nothing. A large sample size is a sample where n is greater or equal to 30. This is how we define a large sample. Now, for a t-test, the sample must be small. So from this definition, a small sample is the one where n is less or equal to 29. You see, from 30 and above, the sample is defined as large. From 29 and below, we define it as small. And now with these two definitions, I would want you to refer to what we call the central limit theorem. Central limit theorem. I want to refer to you to the central limit theorem as an assignment so that you appreciate why do we use a Z-test when n is above 30. That is explained by the central limit theorem. Now, are these the only conditions that we look for? If the sample is large and if the sample is small, for large we use Z, for small we use T. But we should also consider the variance. We should also consider the variance. The variance that we are talking about is the population variance, not the sample variance. Population variance. I will emphasize on this one. Population variance is normally denoted by sigma squared. If the population variance is known, let me say non-population variance. If the population variance is known, then we use Z. If the population variance is unknown, then we use T. So how many conditions do we have? For T-test, the sample must be small and the population variance must be unknown. For Z-test, sample must be large and the population variance must be known. Now one would ask, suppose the population variance is known and the sample is small. How do you proceed? I want to make it clear that these two conditions must be met. If one of the conditions are not met, then you have to use the T. For you to use the Z, sample must be large and not all. And the population variance must be known. If those two conditions are met, then you proceed to use a Z-test. Right? Now, normally I have seen some students being confused when we talk of population variance. If you are given sample variance, that is not population variance. If you are told that the sample variance was so much, that does not mean the population variance is known. For you to use the Z, you must be clearly told that the population variance from which the sample was taken is so much. Then you can easily make use of the Z-test. Now we want to proceed to look at each of these tests, following those steps which I've given, or the ingredients to a test of hypothesis. So we shall look at each of these steps for both the Z and the T test. Now let me start with a T test. Remember what I said? We shall only concentrate on tests involving two populations. Tests involving two populations. Let me give a simple example so that we can use that to explain. Suppose there is a claim that the average yield of mahangu in Namibia was better in 2010 than in 2011. Right?